In today's session, we are going to discuss physical trends. The first physical trend in S block is atomic radii. What is atomic radii? Atomic radii is distance between center of the nucleus and valence shell. Let's consider this atomic radii down the group. The first element is lithium in group 1, followed by sodium and potassium. As we move down the group, number of shell increases, and that's the reason distance between center of the nucleus and valence shell increases. That's why we say as we move down the group, atomic radii increases. Now let's consider across the period. The first element is lithium. The next element in the same period is beryllium. For sodium, the next element is magnesium, and for potassium, next element is calcium. As we move across the period, number of electron increases, and that's the reason charge on nucleus also increases. Because of high nuclear charge, electrons are more attracted towards the nucleus, and that's the reason distance between center of the nucleus and valence shell decreases. So we say as we move across the period, atomic radii decreases. So the trend for atomic radii in S block element is as we move across the period, atomic size or atomic radii decreases, and as we move down the group, atomic size or atomic radii increases. So this was about the first trend in S block element, atomic radii. Let's discuss the next trend, and that is ionic radii. What is ionic radii? Ionic radii is distance between center of the nucleus and valence shell of an ion. So let's consider atomic radii and ionic radii for any particular metal. The first element is lithium, and here is atomic radii for lithium. When I talk about lithium ion, it is Li+, and this ion is formed by removal of one electron. So lithium ionic radii is something like this. And when I compare atomic radii and ionic radii, I get atomic radii is greater than ionic radii, and the values are 152 picometer and 76 picometer. The next element is beryllium, and beryllium's atomic radii is same, increased than ionic radii, and that's why we say the values are 112 picometer and 31 picometer. And that's the reason the trend is atomic radii is greater than ionic radii. So this was about atomic radii and ionic radii in S block elements. So it's a quiz time now. I'll give you 3 questions and you have 40 seconds to solve. Your time starts now. So students, very easy questions, right? Let's see the answer. The first question, as we move down the group, atomic radii increases, remains constant, decreases, and none of the above. The correct answer is as we move down the group, number of shell increases, and that's the reason atomic radii also increases. Answer option A. Second question, as we move across the period, atomic radii increases, remains same, decreases, or none of the above. The correct answer is as we move across the period, nuclear charge increases, and that's the reason atomic radii decreases. Correct answer is C. And the last question, atomic radii of lithium is dash than its ionic radii. Correct answer is for any S block element, atomic radii is always greater than ionic radii. If you got all the 3 questions right, you got 3 on 3. Thank you.